Okay, hello everyone. I welcomes to all in our lecture series on mathematical physics, that is your core paper 8 belongs to 4th semester B.sc physics on our syllabus CBCS model. In our last class, we have been discussed another method or procedure to solve this type of range question. Okay. In this class, we are going to discuss this question. Find Lorentz series of fz equal to z square plus 1 by z into z square plus 3z minus 10 about z0, z equal to 0. In the last class, I told that you can also consider by this method that converting z plus 1 to t, again reconverting z plus 1, we are going to get the same answer. Okay, but I suggest that in which way we have been done, that way you have to practice. Okay, now we are going to go for this question. Here you can see that there is no range has been given, but it has been given that about z equal 0 we have to find out the Lorentz series. So before we have to find this question's Lorentz series, first we have to do the partial fraction of this one, then we can find the exact singular points. So here detail partial fraction I have been done, you have to write in your note. Okay, so quickly I'm going to discuss this partial fraction. By partial fraction, this one z square plus 1 by z into z square plus 3z minus 10 will be written as z square plus 1 by z into z square. This 3z can be written as 5z minus 2z minus 10 is there. That implies z square plus 1 by z into this one will be equal to z square plus 1 by z into, here you can see, I taken z common from these two terms. This will be z plus 5. If I will take minus 2 common from these two terms, then it will be minus 2 into z plus 5 will be equal to z square plus 1 by, here you can see, z already is there. So here z minus 2 into z minus 5. That means if I am going to take z minus 5 common from this and this term, we can write z minus 2 into z minus 5. Sorry, z minus 2 into z plus 5. Let this is your equation number 1. Now, this is the partial fraction. Here I done. This is the first step of the partial fraction, that z square plus 1 by z into this one, z minus 2 into z plus 5 will be written as a by z plus b by z minus 2 plus c by z plus 5. You just add these three terms, we can get in the denominator z into z minus 2 into z plus 5. So here z is there, so a into z minus 2 into z plus 5, b into z plus 5, c into z minus 2 divided by z into z minus 2 into z plus 5. Just multiply these two terms. Here I written z square plus 3z minus 10. Here z square plus 5z, z square minus 2z, denominator is the same. So here you can see what are the z square terms. Here a plus b plus c, z square taken common. Okay, now search the z term. Here you can see 3z, here 5z, here 2z. That means if I am going to multiply a with this one, then it will be 3az, this will be 5bz, this will be minus 2cz. So by taking common z, we can write here 3a plus 5b minus 2c, and one constant term we can get here minus 10a. Okay, divided by the three terms, that is your z into z minus 2 into z plus 5. According to partial fraction method, here you can see the denominator of LHS and RHS is same. So if it is so, if the denominators are same, then according to partial fraction method, the coefficient of each power of z should be equal. Each power means here z square is there. What is its coefficient? Is 1. It should be, this 1 should be equal to a plus b plus c, because a plus b plus c is the coefficient of z square in your RHS. Here you can see there is no z term. That means z term, here we can write suppose 0 into z. Okay, that means there is no z term. The coefficient of z is 0. RHS, the coefficient of z is your 3a plus 5b minus 2c. So 3a plus 5b minus 2c will be equal to 0. Here a plus b plus c will be equal to 1. Minus 10a is the constant. Here will be equal to 1. Got it? This is the partial fraction basic things. These things already we have been discussed in our previous lectures. Okay. Now we got the three equations: a plus b plus c equal to 1, 3a plus 5b minus 2c equal to 0, minus 10a equal to a. So here a equal to minus 1 by 10, and here a I substituted over here. We found b plus c equal to 11 by 10. Here a value I substituted over here. If I will do that, we can get 5b minus 2c equal to 3 by 10. Here we got this equation: 5b minus 2c 3 equal to 3 by 10. Here b plus c equal to 11 by 10. I taken this equation here and multiplied 2. That means 2 multiplied with this equation. Okay. If I'm going to do so, then I'm going to add these two equations. 2c, here 2c got cancel. Here 2b plus 5b, then we are going to add it. If I'm going to add the 2c minus 2c plus 2c got cancelled, and here 5b, 2b, 7b, here 3 by 10, here 2 multiplied with this one, 22 plus 3, 25 by 10, and b will be equal to 5 by 14. But b plus c equal to how much? We know 11 by 10. B, if I'm going to substitute 5 by 14 plus c equal to 11 by 10, then we can get c equal to 26 by 35. So here, after partial fraction, we found a value is your minus 1 by 10, b value is your 5 by 14, and c value is your 26 by 35. So by substituting a, b, c values in this equation, finally we found this one: z square plus 1 by z into z square plus 3z minus 10 will be equal to, here we have been written a by z plus b by z minus 2 plus c by z plus 5. So instead of a, we have to write minus 1 by 10, b 5 by 14, c will be 26 by 35. Let this is your equation number 2, right? But from equation number 1, here it is found that the function has three singular points where the function is not analytic. The singular points are z equal to 0, 2 and minus 5. Here you can put z equal to 0. This term will be 0. That means this function could not be analytic or could not be defined. Z equal to 2, this term will be 0. That means this function could not be analytic. At z equal to minus 5, if I am going to substitute, also the denominator will be 0. That means the value will be infinite, or we can say not analytic. So these are the singular points of this function. As per the question, z0 equal to 0, because as per the question what it has been given, we have to find out the Lorentz series of this one about z equal to 0. Means as per the question, z0 has been given how much? 0. Here I written one thing in the box as the note that you have to remember. This is one particular type of question that it has been given z0 equal to 0. But here we found three singular points: 0, 2, minus 5, where the function is not to be analytic. So in this question, region is not given. So three possible regions has to be considered, because as we got three different singular points, that means we have to consider outer region, we have to consider inner region, and we have to consider also annular region. Okay, because if I'm going to locate all these singular points, here you can see one singular point is at 0. This is the complex plane. At this point is one singular point. At 2, another singular point. minus 5, at minus 5, another singular point. So why I'm telling that we have to consider three regions, here you can see in the question it has been given that we have to find out the Lorentz series about this point, about z equal to 0 point. Now about z equal to 0 point, if the function is going to spread from this point, suppose it is spreading from this point, it will interact with the first singular point in this one. That means this function is going to be stopped over here. In this way you can think. That means we have to consider this region only. Then suppose I'm not going to consider that singular point will be 2. If I'm going to ignore this singular point 2, then it can be spread. It will spread again. It will be interact. It will interact with minus 5, which is the another singular point. There it will be stopped. That means we can consider this entire region. But as we have another singular point here, so we have to consider this annular region. Okay, so if I'm going to consider that the function will be up to 2, that means up to this range, that means we have to consider the inner region. Okay, and also outer region. If we are not going to be consider these singular points 0, 2, 0, 2 and -5, that means function is analytic outer side. So we have to consider three regions: outer region, inner region, because inside this region function is analytic. Inside this annular region, except these two singular points, three singular points, also the function is analytic. Inside this region, except this 0, also it is analytic, right? So as in the question it has been not given which region we have to consider, particularly this type of question, you have to consider the three possible regions. Here three possible regions are z mod less than 2, that means inner region. Z mod less than 2 means it will be from -2 to 2. Z mod greater than 5 means less than -5, greater than 5, that means outer region we have to consider. This is another possible region, because in this region, outer region, in this outer region, the function is analytic. Okay, and this annular region also function is analytic, that means we have to also consider 2 to 5 region, that means this annular region. 5 will be the radius, this is the 5 radius, this is your larger circular radius, this is the smaller circular radius, that means this is the annular region also we have to consider. Remember again, if this type of question has been given, so three possible regions we have to consider. This question will be asked for 6 mark. Carefully you have to watch and write down your note. Now we are going to find the Lorentz series in the region, that is the first bit, z mod less than 2, which is what, inner region, right? For the inner region, z mod less than 2, here I am going to consider the circular equation method to find the region. So if z mod less than 2, that means we can write z minus 0 less than 2. Here 2 is the radius, 0 is the center, center means z0. Which one is the center? That will be considered as your z0. Okay, z0, right? Now we have to find out the Lorentz series of this one, and this one separately. Finding the Lorentz series of 1 by z in this region, in this inner region. Okay, so for this inner region, z0 equal to 0, and z dash for this function, z dash means singular point is 0. So we know that if z0 and z dash will be coincide with each other, the Lorentz series of the function, given function 1 by z, is itself. That means Lorentz series of j 1 by z will be 1 by z. Got it? Next, we have to find out the Lorentz series of 1 by z minus 2 in this region, means in the inner region. So for this case, from the figure we can find z0 is your 0, and z minus 2, 2 is the singular point. 2 is the singular point. So if you are going to standing over here and you are trying to move inside this, that means you are moving out to in. So for this case we are going to consider out to in. If out to in means 1 by z minus 2 will be written as in the form of 1 by z dash minus z0 minus z minus z0 as per the Lorentz series theorem. Z dash 2 substituted, z0 2 substituted. After substituting, you just match. This value is equal to this one. No, this is 1 by z minus 2. Here 1 by 2 minus z we can get. Only for that minus has been multiplied by for equalizing both the side. Now here this is the first term 2, second term is your z. First term 2 taken outside. So this will be minus 2 taken outside, 1 minus z by 2. Here z by 2 will be always less than 1. You can check. Now if it is 1 by 1 minus z by 2, then what will the Lorentz series? N equal summation over n equal 0 to infinity. This one z by 2 to the power n. 1 by 2 minus 1 by 2 is there. So here z by 2 is less than 1 always. You can write, because here you can write because z by 2 is less than 1 in that region. In that region. You can check. Okay, you can check. Now finding 1 by z plus 5 in this region. So here for this case, z dash is what? Minus 5. That is your so-called singular point. Z0 is your 0. So where you are standing? Here you are standing. You are standing over here, minus 5. And you are trying to move in this region. If it is so, that means you are trying to move out to in. Here hints or tricks I haven't written. Out to in. Out to in means 1 by z plus 5 will be written in this format. 1 by z dash minus z0 minus z minus z0. Z dash minus 5, z0 0, Z is arbitrary minus 0. Just match with this one, this one. Here you can see I just hidden this minus, it just match. This is Z plus 5, but here we can find minus 5 minus Z. So if I will multiply minus, then it will be equalized. So here minus 1 minus 5 will be the first term, second term is the minus Z. First term is what? Minus 5 taken outside. So it will be minus 1 minus 5 is the into whole into 1 plus Z by 5. You can check Z by 5 will be always less than 1 in that particular region. So here minus minus got cancelled, 1 by 5 into summation over n equal to 0 to infinity. This one 1 by 1 plus Z by 5 will be minus 1 to the power n summation over Z by 5 to the power n, because 1 by 1 plus x plus means minus 1 to the power n will become 1 minus means this minus 1 to the power n will not come in the series. So minus 1 to the power n Z by 5, but because instead of x here Z by 5 is there. So Z by 5 to the power n. Why? Because Z by 5 will be always less than 1 for this particular region. I am not writing because many times I have been written and you are familiarized for in this type of work. Now LS of given function in this inner region will be, this is our LS original function, and after partial fraction we found this one, this term, this term, this term. So LS of this one means LS of this one in that region, LS of this one, LS of this one. Separately we have been evaluated. Now we are going to substitute 1 by Z LS. How much we found? 1 by Z. Here you can see 1 by Z we found. Okay, 1 by Z का कितना मिला? 1 by Z, वही 1 by Z, और 1 by Z minus 2 का हमको कितना मिला? minus 1 by 2 summation over n equal to 0 to infinity Z by 2 to the n. Same thing I have been substituted over here. 1 by Z plus 5 का कितना मिला? इतना, उसको लेके इधर मैंने सब्सटीट्यूट कर दिया, और this is the required Lorentz series of this function in the given region, or you can say in the inner region. Okay, in the expansion form you can write in this way. And here you can see that this is one term, it belongs, that we can say is your principal part, and this is entire is your what? Analytic part. Because here you can see Z to the power negative power, Z का power इधर negative है, that means Z to the power minus 1 आएगा, सिर्फ एक ही term है. And here if you are going to consider residue will be minus 1 by 10. And these are all belongs to, these terms are all belongs to your analytic part. Okay, now we are going to go for our next region, that is your Z mod greater than 5, that means outer region. Z mod greater than 5 means this region, outer region. Okay, here I am again and again recalling you that just draw the figure perfectly. If you are not going to do the perfectly the figure, then you cannot find the correct information or correct understanding. Okay, do that. Okay, Z mod, given that Z mod greater than 5, that means by circular equation method, Z minus 0, we can write this one greater than 5. Here 0 means the center, which is considered as your Z0, 5 is your radius, right? Now we are going to find out the LS of 1 by Z in that particular region. For this function Z0 is 0, and already given Z dash also 0 for this function 1 by Z, because if I am going to put 0, then it will be not defined, not analytic, so Z dash will be 0, as this is the singular point of this function. So here Z0 and Z dash coincided, so LS of 1 by Z will be 1 by Z. Now we are going to go for LS of 1 by Z minus 2. For this case, Z0 is 0, Z dash is 2. Now, and we are targeting what? Outer region. Here you can see Z dash means you are standing here, and we are trying to move out. Outer region means E into out situation. Here I written E into out situation. If E into out situation, then 1 by Z minus 2 or any function, the denominator will be written in this format, Z minus Z0. For out to in, Z dash minus Z0. Into out, Z minus Z0. Okay, Z minus Z0 minus Z dash minus Z0. Several times I told. Again I am telling that you just remember these two tricks or two formulas what I extracted from your Lorentz series theorem. Because in any Lorentz series, this one is very much required. Always it will be required. You do not forget. For into out, 1 by Z minus Z0 minus Z dash minus Z0. Z is the arbitrary. Z0 is your 0. Z dash is 2. So if I am going to match this one with this one, 1 by Z minus 2, here also 1 by Z minus 2. No need to multiply minus. So we found 1 by Z minus 2. Then you just take common first term. If I am going to take common from this term and this term, this the Z I am going to take common then we can found 1 minus 2 by z. Here one question maybe will be induced in your mind that here 1 by z minus 2 sir you written, and here same thing after doing 2-3 step also 1 by z minus 2. Here in this way you confirmed, no, you confirmed by using Lorentz series theorem. This is the Lorentz series theorem by in to out, that means inner circle to outer. If we moved these things already we have been discussed in detail in the Lorentz series theorem. So here this is the Lorentz series theorem we applied over here and we got this one. And whatever the first term we taken common from these two terms, we found z into 1 minus 2 by z, and here 2 by z automatically it will be less than 1 in that particular region. If you want, I'm going to show you 2 by z in the outer region. Outer region 2 by z, any point. So for the simplicity you consider 5.1. 2 by 5.1 will be how much? Less than 1. Okay, or 6, 2 by 6 also less than 1. So 2 by z is always less than 1 in that particular region. So what will the Lorentz series now for 1 by z minus 2 will be equal to 1 by z, it is there, and this is here can say 1 by 1 minus is there. Minus means we have to write summation over n equal to 0 to infinity 2 by z to the power n. Again I am going to recall you, suggest you just remember these two Lorentz series. 1 by 1 minus x, Lorentz series or the so-called Taylor series. 1 by 1 minus x will be 0 to infinity summation x to the power n. But for 1 plus minus 1 to the n will become extra. And always here x is your less than 1. And for here in the form of 1 by 1 minus x instead of x. Instead of x here 2 by z is there. What we have to write? n 0 to infinity. Here x to the power n. Here 2 by z to the power n. I suggest these two you have to remember always, and these two you have to remember always whenever we are going to solve a Lorentz series in exam or anywhere. For finding now we are going to find the Lorentz series of 1 by z plus 5 in this region. In this region means for the outer region. For the outer region here from the figure z0 is 0, z dash is your minus 5 because z minus 5 is the singular point of this function. But in figure we can found you are standing over here and you are trying to move outer region. Outer region means what? Into out situation. Okay, into out. But whenever we consider this region, you moved from here to here, that means out to in. But for this case you are moving from here to somewhere outside any arbitrary point z, that means into out. That means for here for this region this 1 by z plus 5 will be follow I to O, means into out situation. So into out situation means 1 by z plus 5 will be written as 1 by z minus z0 minus z dash minus z0. Here also we have been discussed the same. So z0 is 0, z dash is minus 5, and we got the same 1 by z plus 5 exactly match. No need to write multiply minus. So if the first term is z taken outside, z into 1 plus 5 by z, and here plus is there. Plus means summation over n equal to 0 to infinity minus 1 to the n into 5 by z to the n. 1 by z is there, 1 by z. So here we found the Lorentz series of this function 1 by z, 1 by z minus 2, 1 by z plus 5 in this particular region means outer region. Now what will the Lorentz series our original function? Original function is nothing but this one. That means original function Lorentz series will be equal Lorentz series of this one. We have to just substitute. Lorentz series of 1 by z is 1 by z written. Lorentz series of 1 by z minus 2 in this particular region here I written. Now the Lorentz series of given function in this outer region, okay, outer region will be 1 by z minus 2 is this one. I have been substituted over here. 1 by z plus 5 Lorentz series is this one have been substituted over here. Okay, काम खत्म. इतना ही आएगा इन दिस रीजन में, मगर वो जो इनर रीजन में उसका अलग आया था. ठीक है, रीजन चेंज हो गया, रीजन चेंज्ड, सीरीज का जो वैल्यू और सीरीज का जो वैल्यू और द format has been changed. In the expansion form you can write this way. Here if I am going to expand I am going to get 1 term, and here I am going to show you. Here I am going to get different residue value, because here minus 1 by 10 1 by z is there, here another 1 by z term is there, here another 1 by z term is there. So 3 terms you have to add then you can calculate the residue, that means coefficient of 1 by z, because 1 by z here for this case, because z0 is 0 no, so 1 by z coefficient will be the residue of that function in this particular region. Okay. See, do not worry about the residue. In detail, we are going to discuss in our forthcoming classes whenever we are going to discuss the residue topic. Okay. Now we are going to go for Lorentz series in the third region, that is your annular region in between 2 to 5. If I am going to write this equation or given region in circular equation form, this will be, this is your smaller radius, this z mod can be written as z minus 0 mod, and here 0 is the center and this is the larger radius. Okay, so what is the annular region? This is the smaller radius 2. If I am going to consider center is the 0 and 2 is the radius, smaller radius, 5 is the radius, larger radius. So this is the annular region. In this region we are going to find out. So first we are going to find out 1 by z Lorentz series in this particular region. Here z0 is 0. For this case z dash also 0, coincided with it is 1 by z. Lorentz series will be itself. Now Lorentz series of 1 by z minus 2 in this region means in this annular region. For this case z0 0 we know, z dash equal to, but into out or out to in most important. Where you are standing here and you are moving this region, this annular region means into out case. Same thing I have written into out. So for into out already we have been calculated for this one by z minus 2, where this one by z minus 2 into out case we found this one. So again I not written this step, I omitted this step and directly I written that 1 by z summation over n equal 0 to infinity 2 by z to the n. Previously we found I written over here. Then Lorentz series of 1 by z plus 5 in this region. That means first we are going to consider here z0 is 0. For this case z dash will be minus 1, minus 5 and in to out or out to in. माइनस 5 में खड़े होकर अगर अनुलर रीजन को तुम आना चाहते हो तो व्हाट विल द सिचुएशन विल बी आउट टू इन केस नो, आउटसाइड से इन को आने जैसा तुमको फील होगा. ठीक है, सो आउट टू इन, सो आउट टू इन सिचुएशन विल बी देयर. आउट टू इन, for out to in of Lorentz series of z 1 by z plus 5 for out to in case already we have been evaluated. Here you can see, here we evaluated Lorentz series of 1 by z plus 5 for out to in case we found this one. Directly I have been substituted there, that 1 by 5 0 to infinity minus 1 to the n z by 5 to the n, directly substituted. Here we found the Lorentz series of 1 by z minus 2, 1 by z plus 5 in the annular region. So our original function is this one, that means this plus this plus this. So Lorentz series of this one means Lorentz series of this one we have to substitute. 1 by z Lorentz series is your 1 by z substituted here. Lorentz series of 1 by z minus 2 in this region I written here. In this region, annular region will be this one, I written over here. And for 1 by z plus 5, 1 by z plus 5, this value I haven't written over here, right. Now if you want you can expand, you can write this one in the expansion form. So we found the Lorentz series of this function in annular region is this one, and in outside of the whole region is this one. Inner, for inside the inner region the Lorentz is this one. Okay, so here I am going to again recall you or suggest you that if this type of question has been given, so you have to consider these three regions. So here you are going to confuse that 6 मार्क के लिए इतना लिखें नहीं, क्या करना है तुमको, ये जो है ना जो पार्शियल फ्रैक्शन इसको थोड़ा स्क्वीज कर लो और कहीं और कर लो. दैट मीन्स यू जस्ट डू इन योर रफ, and this note you should not write. Here I written for you this 3 to 4 line you should not write. Just to draw the figures a small size, it will reduce the space. And again here I written in the expansion form you should not be write, only this form you have to write also. Okay, and if you are going to omit one line, then 1 2 3 in 3 pages you can complete this question, but you need practice a lot. Okay, now we are going to go for the next question, that is your question number 13 find LS of Fz equal to 2z plus 1 by zq plus z square minus 2z in this range. 0 less than z minus 1 mod less than 1. Similar type of question we have been done in question number 11. Here you can see. Here 0 less than z plus 1 less than 1. Here this is your z minus 1 less than 1. 0 less than z minus 1 mod less than 1, and this is a different function. Here I am going to do the partial fraction of this function, and you have to find out the Lorentz series in this only one region. It has been given only one region. See, in the question number 11 we have been solved for these three regions, but in this question only one region is has been given. One range, you can say, one range has been given. What are the region will be come up by solving this one by circular equation method, that we are going to discuss. That means somewhat I am going to show you, going to do for you, and you have to do detail this question. I'm going to do the partial fraction of this question first. Okay, so here is the partial fraction of this function, that is 2z plus 1 by zq plus z square minus 2z can be written as zq plus z square minus 2z, one added and subtracted, plus 1 minus 1. 2z plus 1, here zq minus 1 written first, plus z square minus 2z plus 1. This is in the form of aq minus bq. That means a minus b into a square plus 2 plus ab plus b square. Here a is your z, b is your 1. Okay, ab means z plus 1 plus this is z square minus 2z plus 1 is nothing but z minus 1 whole square. I taken common from these two terms as z minus 1. So z minus 1 taken outside, it will be z square plus 1 plus 1, z square plus z plus 1 plus z minus 1. Okay, so here you can see z 2z plus 1 minus 1 got cancelled, so 2z plus 1 by z minus 1 whole into z square plus z 2z. 2z plus 1 by z minus 1. If I'll take common z from these two terms, we can get z into z plus 2. So finally 2z plus 1 by zq plus z square minus 2z will be equal to 2z plus 1 by z, first I written z minus 1 into z plus 2. So by partial fraction, what we have to write? This is in the form of a by z plus b by z minus 1 plus c by z minus 2. Then you have to add these things. Then you have to what? You have to do all the steps by yourself. Then match the coefficients. Matching the coefficients LHS and RHS. Then solve the equations. You can find a equal to 1 by minus 1 by 2, b equal to 1 by 2, c equal to minus 1 by 2. How you are going to do the matching of the coefficient and blah blah, we have been discussed in our previous question. You can refer that one. Okay, you can refer this previous question. Okay, finally our given function, that is your 2z plus 1 by zq plus z square minus 2z will be written as, instead of a we can write what, minus 1 by 2 into 1 by z plus b is your 1, so it will be 1 by z minus 1, c is your minus 1 by 2, so minus 1 by 2 into 1 by z plus 2. So Lorentz series of this one in this region is nothing but Lorentz series of this one, and this one. We have to find out separately in this region, and we have to substitute. Okay, so how we are going to find out the Lorentz series of this in this particular region? For that we have to define the region from this given range. So first finding the range. Here given that 0 z minus 1 less than 1, that means this is your smaller circle radius of smaller circle, smaller radius, this is your larger radius. See, these things you should not write in your exam. This smaller radius, larger radius, I written for your understanding only. Okay, larger radius, and this is your center. Here 1 is your center, 1 center. So first you just draw the figure. I told that you have to draw the figure perfectly. This is the complex plane. 1 2, 3, 4, 5, -1, -2, -3, -4, -5. This is 1, 2, 3, 4, 5. -1, -1, -2, -3, -4, -5. So where is the center? Center is at here. Okay, center is at 1. This is the center. Okay, and larger radius is 1. At this center, you just take, I told that you have to do this one perfectly, and you have to take this separation of 1, 2, 3, 4, 5 points equally. Okay, then you can found the good figure and correct result. So what is the radius is your larger? For the larger radius is 1. 1 means here this side 1, this side 1. If you draw, and you have to draw a circle by this rounder pencil, by using rounder pencil, then it will give you the perfect circle. Here I don't by hand, so only for that I not got, but okay. So this is the larger circle. What is the inner circle? Inner circle radius is 0. That means it is indicates the same point. Same point. Okay. So from the question Z0 we found 1. That's it. First we found this one, and we have to consider the two circles. One, the larger circle having the radius, that means here. That means in this region we have to find out the Lorentz series of this. So what will the Lorentz series of 1 by z? Finding LS of 1 by z in this region. Okay. For this case, z0 equal to what? 1. Okay, z dash is 0, because for the 0 this function is not to be analytic. Z dash is 0. So if somebody is standing at 1, okay, sorry, at z dash means here, standing at z dash, this is the z dash, no, for this function, standing at here at 0 standing and moving inside this region to any one of the point, that means out to in situation. So for this case, out to in situation means 1 by z will be written in this format, that 1 by z dash minus z0 minus z minus z0, right? So will be equal to 1 by z dash is your what? 0 minus here z0 is your 1, then minus z minus z0 is your 0. Okay, here you can see, if I'm going to compare with the original, wait, see, z0 is 1 here, I mistakenly written, so z0 is 1. So here if I'm going to compare this and this, is it matched? Here you can see -1, this is minus and minus plus, both are cancelled, but here we found minus 1 by z, so only for that I have to multiply minus, right? Then what we got? We got 1 by, here I told that you do not remove this bracket. So here is it will be number, you can remove this bracket, that is your, we found here -1, and here z is there, means you should not remove this bracket, most important. Then you have to consider the first term, and you just take, here minus is there, just take this -1 outside, or take common from these two terms. What you can get? You can get -1 by -1 taken common means 1 plus z minus 1, right? Z minus 1. So here minus got cancelled, and you found 1 by 1 plus z minus 1. Here z minus 1 always be less than 1 in this region. You can check. Take any value of z. Suppose I am going to take z equal to 0.5. This here it will be, the value will be 0.5. So 0.5 minus 1, it will be value in the minus, so less than 1. If I am going to consider 1.9, suppose here 1.9 minus 1, also less than 1, right? So as this is the less than 1, this z minus 1 value is less than 1, then this series will be equal to n equal to 0 to infinity minus 1 to the power n into z minus 1 to the power n. So 1 by z Lorentz series in this region will be equal to this one. Got it? Now we are going to go for our 1 by z minus 1. 1 by z minus 1. So we have to find out LS of, we have to find out, okay, ठीक है मैं कर देता हूँ, ठीक है, LS of 1 by z minus 1 in this region. So for this case, from the figure itself, for this case, what is the z dash? Z dash is your 1, and z0 already from the figure we found that g also 1. Got it? If I'm going to put 1, this function could not be defined or not analytic. That means it's a singular point. This is the singular point of this function, right? And z0 already we know the center of the circle is 1, right? So if it is so, then what will be its Lorentz series? Here both z dash and z0 coincided. Therefore, ls of 1 by z minus 5 will be itself, that is your 1 by z minus 1. Now we are going to go for ls of third one, that is your here z plus 2, 1 by z plus 2, 1 by z plus 2. So from the figure, for this case, what is the z dash? Z dash is minus 2 and z0 already we know that is 1. Now, if z dash is minus 2, stand over there, go there and stand. Z equal to minus 2 here. Here z is a minus 2 here, right? Z is the minus 2. So here you are standing and you are trying to move in this region. What is the situation? Out to in situation. If you are moving this from this point to this point, that means out to in situation. So just write that. That is your tricks or hints. This case is your out to in case. Out to in case. If it is so, then 1 by z plus 2 will be written as what? 1 by z dash minus z0 by using the Lorentz series. Okay, z minus z0. Okay, so 1 by z dash is your minus 2, z0 your 1, so this will be minus 1 minus z0 is your 1 minus 1. Got it? I told that do not remove the bracket, but here it is a number, so you can remove the bracket. This is the minus 3 minus z minus 1, and here you have to check first that this one is matched with this one or not. You can see minus 3 here plus 1, minus 2 minus z. Here we found 1 by minus 2 minus z, but we have 1 by z plus 2. That means we have to multiply a minus. So this is the minus. Then you take common the first term, minus 3. What you can get? Minus 1. Taken common minus 3 from these two terms. We found 1 plus z minus 1 by 3. You can check, always z minus 1 by 3 will be less than 1 for this for in this region, right? You can, if you want, you can check. Suppose you are going to take 1.5. Okay, this point 1.5, 1.5 minus 1 is your how much? 0.5 by 3, less than 1. Okay, here we found 1 by 3 into 1 plus z minus 1 by 3. So as z minus 1 by 3 is always less than 1 in that region, so Lorentz series of this one will be how much? Already 1 by 3 is there. This will be summation over n equal to 0 to infinity minus 1 to the n z minus 1 by 3 to the power n. Okay. Okay, now we are going to substitute the Lorentz series of this one and 1 by z in our original equation. Here the Lorentz series of this function will be, now we have to write the ls of 2z plus 1 by zq plus z square minus 2z, or we can write in this format, that is your minus 1 by 2 into 1 by z, then plus 1 by z minus 1, then minus 1 by 2 into 1 by z plus 2. The Lorentz series of this one means Lorentz series of this one and this one. Already we have been found, we have to just substitute. That will be equal to minus 1 by 2, 1 by z Lorentz series, how much we found? Here, minus 1 to the power n, z minus 1 to the power n. You have to just write summation over n equal to 0 to infinity minus 1 to the power n, z minus 1 to the power n. Then 1 by z Lorentz series, here we found itself 1 by z. We have to just write 1 by z minus 1, 1 by z minus 1, then minus 1 by 2, 1 by z plus 2, we found this one. Just write 1 by 3 summation over n equal to 0 to infinity minus 1 to the power n z minus 1 by 3 to the power n. So this is the Lorentz series, required Lorentz series of this given function in that particular region. If you want, you can write in the expansion form also. But up to this much you can, if you are writing your examines, you are going to get the full mark, no problem. So here we almost completed the Lorentz series and corresponding different type of numericals. In the next class, we are going to discuss what we have been studied in the Lorentz series and corresponding numericals and some other basic numericals regarding Lorentz series. So in our next class, a revision of Lorentz series where we are going to do, plus some basic questions, some basic questions we are going to discuss in our next class. So next class will be the most important class and last class of your Lorentz series. Okay, thank you so much for watching this video. Thank you.